All right, guys, let's get back to multiplying madness. So I left off on our trinomials times trinomials, which is just nutty. Normally, I like to set up a 3x3 box to do that, but I'm going to skip that last one. Let's just jump into area. So area is interesting as well. We can use that to bring the real world into multiplying polynomials. So find the area of a square with a side length of x minus 3. Well, to find the area of a square, we can do base times height. But really, in a square, the base and height are kind of the same. So really, we just call that side squared. So when they tell me that the side is x minus 3, I need to do x minus 3 times itself. And so we're doing a binomial times a binomial. So we can do that one of a couple of ways. We can distribute twice. We can remember FOIL. We can old school multiply, or we can set up a box. So I'm just going to do distribute twice. So I'm going to do x times x, which is x to the second, x times negative 3, which is negative 3x. Then I distribute here, and negative 3 times x is negative 3x. And then negative 3 times negative 3 is positive 9. I have my like terms in the middle. Negative 3x and negative 3x is negative 6x. Plus 9 is my final answer. Which feels like undone because we don't actually know what the area of the square is, but it's like represented. On to the next, find the area of a rectangle with a length of x plus 2 and a width of 2x plus 4. So area of a rectangle is base times height, and I can't change it to side squared because in a rectangle, the two sides are different. So we're just going to do the base and height, or the length and width, as x plus 2 times 2x minus 4. Now, this is just like the last one, but on this one, maybe I'll set it up as a box. And along the top, I'll put the x and the 2, and then along the side, I'll do the 2x minus 4, and then multiply it to get each square. So we'll have 2x squared, 4x, negative 4x, and then, nope, right here, negative 8. That was almost a goof up, right? Did I get these all correct? So 2x squared, 4x, negative 8. Now, the interesting thing here is that the 4x and negative 4x add up to 0. So really, I just have 2x squared minus 8 as my final answer. That's fun. All right, jumping down, find the area of a triangle. So area of a triangle is half base times height. So this is a little bit interesting because we're going to be multiplying three numbers, half, the base, and the height. So we'll just do those one at a time. So calling the base x plus 4, and then the height x plus 6, although it doesn't really matter the order that we put them in. First, I would multiply my two sets of parentheses, and then I would multiply the half. It kind of doesn't matter, but I just like to get the hard part done first. So if I'm going to do a 2 by 2, I'm going to remember FOIL, first, outer, inner, last. So first is x squared, outer is 6x, inner is 4x, and last is 24. Now all of this is still getting multiplied by half. But before I do that, I'm going to combine my like terms. So we'll have x squared plus 10x plus 24. And then I'm just going to distribute the half through. So half x squared, and then half of 10 is 5, and half of 24 is 12. And so there's our final answer. And then last but not least, kind of interestingly, we can do this with a circle as well. To find the area of a circle, we're going to do pi r squared. So kind of like the last one, the pi is going to chill out front for a little bit. Like I'm going to multiply that at the end. And then also kind of like the square, when I have a number squared, that means I'm taking that radius and multiplying it by itself. Notice that I'm like not distributing the exponent. I have to write it down twice and multiply. So like the triangle one, I'm going to multiply these two first, and then I'll distribute the pi through. So this time I'll do like old school multiply where I line them up. -1 times -1 is +1. -1 times x is -1x. Placeholder, -1x, and then x squared. And I add down, so 1, -2x, x squared, and then all of this is still being multiplied by pi. And so then I would distribute the pi through, and so we'd have pi x squared minus 2 pi x, and it's kind of mathematically appropriate to put the pi in the middle because it's kind of a number, kind of a letter. And then lastly, multiplying pi times 1 is just pi. Sorry, that's real squeezed in there at the bottom. Also, my screen, and I don't know if you can see this, is doing a really funny color again. Alrighty, last but not least on this page here, we have binomial times binomial times binomial, which again is kind of like the triangle problem because I'm multiplying 3 things. And I can't multiply 3 things all at once. I really have to do 2 and then do the third. So I can multiply these 2 first by doing distribute twice. So we'd have x times x for x squared, and then 6x, and then -4x, and then -24, and then combine my like terms. Now all of this is being multiplied by the x plus 2. And so now what I have is a trinomial times a binomial. And for me personally, the easiest way to make sure I don't accidentally forget to multiply something is to set up a box. Now this one is going to be a 3 by 2 because I have 3 numbers here and 2 numbers in the second one. So we'll have x squared, 2x, and -24. And then we'll have x and 2 on the top. And then I'm going to multiply to get each square. So x squared times x is x to the third, 2x squared. When I line these up, we get 2x squared. Here we get 4x. And then lastly, we get -24x. And then -48. Along the diagonals, we should have our like terms. So right here and right there. So we have x to the third, 4x squared, -20x, and then -48. Now, I didn't necessarily have to multiply the front 2 first. So let's try one more. And in this one, I'm going to multiply the back 2 first. You could honestly do the front one and the back one, but that's just kind of awkward because they're not next to each other, but you could do that. So let's say I multiply these 2 first. If I do, I don't know, let's go over here and do a box. 2 by 2 because we got 2 numbers in the first and 2 numbers in the second. So x times x is x squared, 3x, -3x, -9. Along the diagonals, I have my like terms, and actually 3x and -3x is 0. So this is going to just turn into x squared minus 9. And then I have to still take care of the x minus 7. Now this time, this one's actually easier. It's 2 numbers by 2 numbers again. So maybe this time I'll just do distribute twice. So x times x squared is x to the third. X times -9 is -9x. Then we get -7x squared, and then +63. Now I don't have any other like terms, but I do want to put this in standard form, so I'm going to rearrange these middle 2 numbers just so that the x squared comes before the x. And there you go. All of the multiplying fun It's endless. See you in the next one.